Hello and welcome back to another video lecture from Architects Academy. Today's lecture is going to be about two-way slab, RCC two-way slab. So in our earlier lecture we had learned about RCC one-way slab. In this lecture we are going to learn about two-way slab. So let me zoom into this plan. This is showing a plan of a room which is of a dimension of 6 meters by 4.5 meters. You can see that the room is bounded by 4 columns, C1, C2, C3 and C4, and there are 4 beams, B1, B2, B3 and B4. Now since the dimensions of the room are 6 meter by 4.5 meter, if we take the ratio of 6 by 4.5, this ratio is less than 2. So we know from our earlier lecture that when the ratio of the length to the breadth is less than 2, the slab is designed like a two-way slab. What it means is that whatever load is coming on the slab, it is going to travel in both directions, along the longer direction and along the shorter direction. So that's why this is going to be designed as a two-way slab. Another meaning of it being a two-way slab is that the main reinforcement in this slab is also going to run in both directions, along the longer direction and along the shorter direction. So what you are seeing here is the reinforcement inside the slab. The bar which I am now highlighting here, the red colored reinforcement bar, this bar is the main reinforcement inside the slab. As you can see, this bar is bent up after a certain distance. So that certain distance from after which it is bent is L by 4, which you can see here, that the distance from the edge of the beam to the point where the bar starts bending up is L by 4, that is 6000 by 4 in this case, this works out to 1500. So this is how the main reinforcement inside the slab is. So what you will see here is that the alternate bars, this bar, then this bar, these alternate bars are bent on the left hand side here, while as the other alternate bars are bent up like this on the right hand side. So alternate bars in this slab are bent up. The reason for the bars being bent up at this distance of L by 4 we had seen last time in the lecture on one-way slab, but we'll see that again later on, why these bars need to be bent up. So you will see that this is the main reinforcement in the longer direction, and you will also see that in the shorter direction also the similar type of reinforcement continues. So these two main reinforcements are crisscrossing each other. The distance between the reinforcement is governed by the structural drawing, the calculations based on structural drawing, and the diameter of the bars are also based on the design of the slab, the structural design of the slab. You will see that on this side also the alternate bars are bent up at a distance of L by 4. Now because the length in this direction is 4.5 meters, as you can see here, this distance of the bent up bar is L by 4, that is 4500 by 4, that is roughly around 1100 distance. This bar will start getting bent up like this. This bent up bar is being bent up at an angle of 45 degrees. So as I had explained in the video on the one-way slab, though we are seeing this bar like this placed horizontally like this in bent up fashion, in actual reality this bar is a straight bar, and the bent up portion is along the Z axis. It is not along this X and Y axis. But because we cannot show this bent up in the Z axis in plan, that is why we are showing it purposefully like this, as if it is flat on its face. So this is just a way of indicating the bent up bar which is shown in the structural drawings. The load from this slab is now obviously going to be transmitted along this reinforcement bars, and it is going to go to all the beams B1, B2, B3 and B4. Though there are only few bars shown here in both the shorter direction and the longer direction, in actual reality this entire length and width of this slab will have these types of bars in both directions. Now we had seen that in case of the one-way slab, we required to have distribution steel at right angles to the main reinforcement. The purpose of the distribution steel was to distribute the load evenly over the entire slab. In this particular case, since this is a two-way slab and the main reinforcement is in both directions, there is no need for having any distribution steel. In fact, there is no distribution steel in the two-way slab. So this is how the plan of the two-way slab looks like. Now if we take sections through this slab, like for example section AA along the shorter direction and section BB along the longer direction, we will see something like this which we are seeing here. So let us first see the section AA, which is going along the shorter direction. If we zoom into this section, what you will see is that we will see the main reinforcement which has been shown here in the red color, which is going right from beam B2 to beam B1. You will also see that the bar is bent up here at a distance of L/4, and it goes inside the slab and it is getting anchored inside the beam. Similarly, you will see on the right hand side, this bar is going inside the beam and it is getting anchored up to a certain distance here. The reason for that I had mentioned in the case of the one-way slab, that is to get the necessary development length for the bar. That means that when the slab bends, the tendency of the bar, reinforcement bar, is also to bend, and thereby it has a tendency to get pulled out of the beam. So to maintain a sufficient grip of the concrete with the reinforcement needs to be anchored up to a certain length inside the beam. This is called as the development length of this bar. We'll see more about development length in another video further. Now what you will see is that there are some lines which are shown in dashed lines. This is a dashed line here, and then you will see these dashed lines here also. What it means is that these are alternate bars which are seen beyond this bar in the slab. So that's why they have been shown as dashed. So what you will see here is that it has been written here that dashed lines indicate bars beyond the section line, while as the bar which is shown in the continuous line is the bar which is seen in section. You will also realize that this bent up bar the bar is bent up at an angle of 45 degrees. The reason for that is that the shear resistance which is given by the bent up bar, the shear acts at an angle of 45 degrees and therefore the bar is in the opposite direction of the crack formation, shear crack formation, and therefore it is at 45 degrees like this. We'll see more about shear force in some other later video, but just remember that there are alternate bars which are bent up like this at L/4 from the beam. The rest of the reinforcement, as you can see, that you can see these red colored dots which you can see here. This is the reinforcement coming along the other direction. Like for example, if you are taking this section AA, whatever bars are getting cut here those bars are being seen here along this in the form of these red dots. So this is going to be the reinforcement along the longer direction which we are seeing. We'll also see that reinforcement inside the beam is seen here, similar to what we had seen in the one-way slab. There are 2 anchor bars at the top, 3 main bars at the bottom, and they are connected by the rings which are called as the stirrups. Now the similar section will be seen along the section line BB, as you can see here. So if we take a section along the BB direction here, the section will be very similar to what you are going to see along the AA direction. So nothing much has changed except for the distance of the bent up bar, which is now L by 4 of the longer dimension, that is 6000 by 4. And as you can see here also, this dashed line which you are seeing here, this dashed line is indicating the alternate bar, and at a distance of 1500, that is L by 4 from the face of the beam. So the section AA and section BB are very similar to each other. There is no major difference in the sections. Now, what is the reason for having this bent up bar, and what is the distance for having the bending? Why do we require to have the change the face of the reinforcement? Why it is to go at the upper face? For example, if you read this note, what you will see is that alternate bars bent up at L by 4 for resisting shear and for taking bars to the top face to resist the negative bending moment. So what does that really mean? So let us look at it by studying the bending moment diagram of the slab. So what you will see is that when the slab bends like this, you will see that this dashed line is indicating the type of bending that is occurring inside this slab. So what you will see is this: in the center there is some sagging which is occurring, and at the supports there is upward bending which is occurring, which we call as the hogging. So you will realize that wherever there is a bending occurring, there is going to be tension here. So tension at the bottom here. Here the tension zone will be at the top, tension zone at the top. So what we call here, this particular part is the positive bending moment, and this part is the negative bending moment. The same thing which we can see in the bending moment diagram. So if we draw the bending moment diagram, what you will see is that the bending moment is positive in the center, and at the support it becomes negative. So wherever there is a bending moment or wherever there is tension, we require to have the steel at that particular point. So you will realize that at this particular point where the bending, the tension now becomes sort of, it changes the face from the lower face to the upper face, we require to take the steel at the upper part of this slab. So that is precisely what is happening out here, that at a point where there is going to be, so this negative bending moment is going to start, or where this tension zone is going to change, we require to have this main reinforcement at the top. So by looking at the bending moment diagram and looking at this diagram where the bending has been shown, we can easily understand why the steel has to change the face from the lower face to the upper face in the slab. Similarly, here what you are seeing is the shear force diagram. Of course, both these diagrams are drawn considering that there is a uniformly distributed load, or UDL. So what you will see is that the shear is maximum at the supports and it becomes 0 in the center. So at the points where the shear is maximum, you will see that we need to have something to resist the shear. So one of the functions of this bent up bar here is also to give the resistance to the shear at the point where the shear will start becoming maximum. So that's what has been now given in this note, the reasons for bent up bar in the slab. So what are the reasons for the bent up bar in the slab? Number one is that the reinforcement near the support changes location from lower part of the slab to upper part of the slab as per the change in the tension zone as shown in the diagram. So the tension zone shifts from the lower part of the slab to the upper part of the slab, and therefore the same way reinforcement also changes the face. The second important reason is that the bent up bar resists the shear stresses near the support. So that is the second reason for having the bent up bar. Now the next thing which we had seen was related to the one-way slab. So this particular thing will not apply here. So this is now not applicable for the two-way slab, because the simple reason is that there is no distribution steel in this slab. So I hope the drawing for two-way reinforcement, two-way slab is clear to you. In the exam you will be asked a question on this, in which you will be given only the dimensions of the room and nothing will be mentioned which is whether it is going to be a one-way slab or two-way slab. Depending upon the dimensions of the room given, you will have to work out the ratio of the length to the breadth and find out what is the ratio. If the ratio between the length to breadth is 2 or more than 2, then obviously it will be one-way slab. But if the ratio between the length to breadth is less than 2, then it is going to be a two-way slab. So this is how you will be making a drawing. Show the proper indication for bent up bars. Show the distance of the bent up bar from the edge of the beam. Mention that it is L/4 from the support. Write all these different reasons or whatever notes are there, right on the drawing itself. So this is very important. Draw the sections, 2 sections through the slab, and also write the notes directly on the section itself, which will be explaining some of the important concepts in the two-way slab or one-way slab. So it is important that all that you know has to be actually try to show it in the drawing itself, in the section itself. Don't forget to show the reinforcement in the beam, and also mention anchor bar, stirrups, main reinforcement in beam, and so on. So I hope this is clear to you, and I'm sure that now you'll be able to attempt the question on two-way slab if it is asked in your exams. Thank you.